Because with Communication Manager, you only have one server active and the other ones are in a standby. And here with Session Manager, all of your session managers are active.
It's load balanced. It's not geographic load out, it's just load balanced.
Yeah, yeah. So pretty much the benefit, and you just said it. Let's actually compare these with CM first. So again, what I'm saying is that actually let's have this. With CM, you have one server as the active one, and then you have another server as a standby server, and that's what in CM we call an LSP or an ESS, right?
Right.
Either an ESS or an LSP. So if you have phones here, let's say you have, I don't know, 10,000 phones. All of your phones, in this case H323 phones, register with this CM, and if this CM goes down, they register with the ESS LSP. Okay? Now, if this is not CM, but this is Session Manager, you have a Session Manager here and another Session Manager here, you have the two of them active. Which means that you could still do the same thing you're doing here. Actually, this would be not H223 phones, but SIP phones. You could still register the 10,000 users to let's say Session Manager 1. This is Session Manager 2. And that's okay. And if that Session Manager 1 goes down, they'll all register they'll all go to Session Manager 2. However, you're not taking advantage of the fact that the two of them are active. A better approach would be, instead of registering instead of having all of these 10,000 phones going to this Session Manager 1 here, a better approach would be to split the users in half. So 5,000 of those users go to this Session Manager 1 as the primary Session Manager, and go to Session Manager 2 as the secondary Session Manager. And then the other half, do the opposite. Go to this Session Manager as the primary, and go to this Session Manager as the secondary Session Manager. So, the benefit of doing something like this is that if Session Manager 1 goes down, there's only a service interruption for half of the users. For the other half, nothing happened. Okay?
What kind of failover registration happens? I mean, can the phones then that are interrupted, so SM1
that's a good
black
question.
hole, can they automatically fall to SM2?
Yeah, and you're gonna see that the phones register when you register the phones register to both Session Managers. So if you're tracing, you'll see a registration in both Session Managers. However, the phones only subscribe to the primary Session Manager, and it's because of those subscriptions that the phones are actually able to get service and features coming from CN.
So how does it determine which one that it subscribes to?
Because it always subscribes to the primary Session Manager. So when you configure your SIP phone in Session Manager,
that's
you tell Session Manager, this is your primary Session Manager, and this is your secondary Session Manager.
And is it only primary and secondary if you've got a fleet of the session managers?
Yes.
There's only two of them that are your potential registration.
Yeah, another good question. So you could have 10 session managers in your cluster, but the phone is only able to register to two of them at the same time.
That's a
and
feature then.
if you have a branch session manager, the phone could register to that branch session manager as a third point of survivability. So each SIP phone could register to 2 session managers in the main core and 1 branch session manager. So 3 session managers. However, even though it registered to the 3 session managers, it only subscribed to events on the primary. So if the primary goes down, you'll see that the phone is already registered to the secondary, and it only tries to subscribe to events on the secondary. So that's a main difference with H223 phones, because with H223 phones, the phones have to subscribe, to register with the LSP. And that registration takes time, especially when you have a lot of phones. You know, like if you have 10,000 phones, 20,000 phones, and they need to now register with the other CM, the LSP or ESS, they need to be placed in queue because that LSP or ESS can only take certain amount of registrations per second. So that's a big difference. Now that the SIP phones are already registered with the other session manager, all they need to do is subscribe with that session manager. So the failover of a SIP phone, if you compare it with the failover of an H223 device, is way quicker.
Okay, what about whenever that service is returned to the primary?
It's the restoration, yeah.
You could, as with CM, configure an auto fallback
Right.
or a manual fallback. Yeah. So you know, like this scenario has two benefits. One of them is that if one session manager goes down, only half of the users are affected.
Right.
And the other benefit is that for the half of the users that are affected, since they already registered with the secondary session manager, the failover of those users is quick because they don't need to register again. They just need to subscribe to some events that we'll cover later. You're gonna see that there are 5 events that the phones need to subscribe to in order to get service from that session manager and also get features coming from CM.
You guys will go over that later?
Because
You'll
what?
go over those 5 features?
Yeah, I'll
later?
go over those
Okay.
events. Actually, so there are
Events?
5 events that the phone need to subscribe.
Okay.
This requires manual intervention from the user?
No,
Okay.
no.
So 12 instances might be a little misleading because you can only use 2 per phone.
Yeah, so those 12 instances are used more for routing purposes, so that you have survivability in terms of routing.
Okay.
For the SIP phone survivability, you can only actually use 2 instances out of those 12.
So as a network administrator, even if you're gonna have more than 2 session managers, you need to set up front what your primary and your secondary is gonna be
Yes.
for your telephone endpoints, your SIP endpoints.
Well,
Yes.
could you not in one system have, you can register different 10,000 to 2 different sets of session managers, right?
Right, could you
have to
do that?
just use
Yeah,
2 in one, right? It's just that one phone can only register register to 2
yeah.
Right.
It's up to you if you want to load balance those session
or
managers.
geographic.
Yeah.
Right, I got you.
Each
Yeah.
session manager supports up to 21,000
Endpoints.
endpoints. It's 21,500 endpoints. So, and there are some menus that allow you to redistribute and load balance session managers. That thing is done manually. You know, like if you realize that one session manager has too many users as the primary, then you could redistribute those users with some menus. But that redistribution is not done automatically, but you as the administrator do it.
Okay.
CM is a little bit different because CM is actually capable of load balance those registrations.
Okay.
So Avaya, I mean these groups that you see here, 2 groups, Avaya referred to them as communities. So in this case it's 2
Two communities.
communities. If you have 3 session managers, as you see there, it would be 3 communities. And back in the day, there was a question in a certification that I didn't see this time, where you had more session managers, like let's say 4 session managers, and the question is, if you want to load balance the registrations of SIP phones, how many communities would you need to create? You know, and it's easy to see it with 2 session managers, maybe not that hard to see it with 3 session managers, but the more session managers you have, the more complicated the picture gets. So for example, if you have 4 session managers. It's gonna be hard, but usually what I do to see how many communities I need to have to load balance users, I will do like this. So let me see, I'm gonna create a table here. Session manager 1, session manager 2, session manager 3, and session manager 4. So since I know that a user can only register to 2 session managers at a time, then one community, let's say it's gonna be session manager 1 and 2.
Yeah.
Another community would be session manager 1 and 3.
Mhm.
Another community would be 1 and 4, right? So let's see, this is 1, this is 2, this is 3, what else? Session manager 2 and 3.
2 and 4, 3 and 4.
2 and 4, you got it. And then
That's 10.
3 and 4,
Yep.
right? So how many?
6.
6
Yeah,
communities,
6, okay.
right? 1, 2, 3, 4, 5, 6 communities. And then half of the users in community 1 would register to session manager 1 as primary, and the other half to session manager 2 as secondary. And no, let me rephrase this. So one half of this community, half of the users in this community will use session manager 1 as primary, and the other half session manager 2 as primary,
Right.
right?
Okay.
Okay. Pretty much what I was saying, session manager, your session managers are all active and your SIP phones are able to register to 2 of them at the same time, and potentially a branch session manager as a third point if you have a branch session manager.
That said there was no,
Yeah.
flip back, that says, no,
There.
freeze, middle, right in the middle, no disruption to any SIP phone during any SM failure. Be magical, right?
It's not completely true.
Okay.
Yeah.
Maybe nothing happens to the phone, but I'm sure the phone dies.
Yeah.
Let me think about it.
That's okay, it's fine. They'll find out, you guys will, right?
No, there'll be a disruption for sure. There'll be a disruption. For at least half of the users.
I mean, in a way, maybe there's not, because if the session manager itself, that server, was all that was affected, then your call would stay active, because it has nothing to do with your call.
Right.
And then when you hang up, you would, subscribe to the other. So if you look at it like that.
Your voice stays up.
Right.
Yeah.
You can look at it like that. That's, a lot of the product is that way right now, and it'll just re-register. But the odds, it's only if the only problem is, it's that session line.
Yep.
If you had a WAN failure or something,
Yeah, if you see it like that,
You've done
yeah, we
it.
could say that
Yeah.
it's true.
Right.
There is a calculator that Avaya uses. This is more useful for when you're trying to design a system. You know, this is more used by pre-sales and salespeople. You know, and this calculator allows you to calculate the amount of session managers that you would need if you have certain amount of users and you wanna work with a n-1 over n redundancy, which means n-1 over n means that you could lose one session manager and still provide service to all of your SIP users. n-2 would mean that you could lose 2 session managers and still provide service to all of your SIP users. So this is just a calculator for you to see, you know, how many session managers you would need based on the amount of users, or vice versa. You could say, hey, I have this amount of session managers. How many users could I have if I want to work with an n-1 over n redundancy? We don't need to actually go in that detail. This is the place
Okay.
later where you specify the primary session manager of each user, the secondary session manager, and the branch session manager. And I don't know why they didn't call here branch session manager. They call it the survivability server, but it's the branch session manager, you know? So those are the 3 points that each SIP phone could register to. Remember, it registers to the 3 points. It only subscribes to events on the primary session manager.
But the primary session manager changed if there's an outage in the other, right?
Yeah.
Okay.
Then if there is, what, no, hold on, what do you mean?
Go back one. So it's a primary session manager, you said it subscribes to that. So if it loses the primary session manager.
It'll try the secondary. If it cannot reach the secondary, it'll try.
But if it can reach the secondary, is it then subscribing to
Yeah.
the secondary?
Yeah, it subscribes to events.
So it can subscribe to either, but
Yeah.
it goes to the primary first.
Yeah.
Okay.
It only subscribes to events on one session manager at a time.
At a time.
But it registers
Makes
to
sense.
all 3
That
session
makes more
managers
sense.
at the
Saying
same
that,
time.
that makes
Yeah. Okay, branch session manager. So that allows you to have remote survivability. In release 6.3, we had templates, and the templates that had the LSP or the ESS, that template was the same template that had the branch session manager. So pretty much what I'm saying is that you have an LSP or ESS in 6.3. In that template, you also have your branch session manager. Maybe you're not using it, but it's there. In release 7, the branch session manager is a completely separate OVA, separate virtual machine that you could install on top of any server as long as you have enough resources. So actually that I'm talking about that, maybe it could be useful to talk about some differences between 6.3 and 7. So in 6.3, and actually let's say 6, because this is more a 6 approach, you have your server, say that's the hardware. On top of that hardware, you have a hypervisor. The hypervisor allows you to later install virtual machines on top of it. So the hypervisor in release 6, Avaya call it system platform. Okay, system platform is the name of the hypervisor, and it was a customization that Avaya did of another hypervisor. I think it was the CentOS hypervisor. Avaya customized it a little bit, and they call it system platform. So with that hypervisor, well, actually that hypervisor installs 2 virtual machines. One is the domain 0. Have you heard of that one? Domain 0.
Yeah.
That virtual machine allows you to do things related to the hypervisor. And it has another virtual machine called cdomain, or the console domain. And that one allows you to do certain things related to something that Avaya calls a template. This is something that Avaya says it calls a template. And in that template, you have applications. You could have different applications. Maybe system manager is one of them. Maybe session manager. Maybe CM. The thing with the templates is that the applications inside the template are fixed. You cannot remove applications from the template, or you cannot add applications to the template. So for example, if for some reason you wanted to have in this environment now an AES, you cannot add the AES here because you would have to remove the template completely. Okay? What I'm saying is that you're pretty much limited to whatever, to the applications that you have in the template, and Avaya has different templates.
So they're all packaged together.
They're all
It's an
packaged
all or
together.
none.
So it could be that you have a lot of resources here, a lot of memory, a lot of CPU, but you have to work with whatever Avaya gave you in that template.
Okay.
Okay? All you can do is install new templates and remove templates, but you cannot add new applications to a template.
Off of the seed.
And that was kind of a limitation, because sometimes the customers were like, hey, but I have a lot of resources in this server. You know? Why is that I cannot add more applications? So that's the big change with 7.
Do you think that's what drove the change?
I think that was one of the things that drove the change. And the other thing is the fact that Avaya was also in 6 already starting to deal with VMware. And there was
That's
right?
it, yeah.
Yeah, I think Avaya didn't want to be in the
Hardware.
virtual platform business.
They were gonna
Yeah,
lose.
they wanted to-
VMware was doing
And-
it better than anybody else,
Yeah.
probably.
They were gonna lose.
Yeah, and VMware already had like 70% of the customers
Yeah.
that were dealing with virtualization. So yeah, but in 6 there was another flavor, right? That it was with VMware. Already in SIP, VMware was an option that you could have as the hypervisor. Anyways, so in 7, the big difference is that you still have your hardware, and Avaya changed the hypervisor.
Somebody's hardware, it might not be Avaya's hardware.
Could be Avaya. That's a good thing. Could be Avaya or non-Avaya. If it's Avaya hardware, one of the common servers that Avaya uses, either the HP server, the Dell server, or maybe an 8300, then the Avaya changed the hypervisor and now it's working with a VMware hypervisor. If you're working with one of the Avaya common servers or the 8300, then Avaya called the hypervisor the AVP.
That was really brilliant of them, by the way. Of course, that's Avaya Voice Portal.
And Appliance voice power.
Yeah,
That's what
It
I
stands
voice
for-
powers are gold.
I know, it's stuff.
It stands for Appliance Virtualization Platform. Easy to remember would be Aliens versus Predator. A good way to remember. But the AVP is nothing more than a customization of the VMware hypervisor, which actually known as the ESXi hypervisor. So that's the new hypervisor, and then on top of that, you install as many virtual machines as you can, depending on the resources that you have here on the server. So now you have the flexibility to install or remove virtual machines from the hypervisor. There is another flavor where instead of going with the AVP, you just go directly with the VMware hypervisor, ESXi. The truth is that AVP and the ESXi, I mean the AVP is just ESXi.
It's
To the
slightly
naked eye,
limited.
to the naked eye is exactly the same. The difference with the AVP, or one of the difference with the AVP, is that if you go with the AVP, you don't need to buy a license for the server. Because in VMware, you need to buy licenses for your servers, but that's something that you don't have to do with Avaya normally. You only buy licenses for the applications, not for the server. But in VMware, you need to buy a license for the server. So Avaya has an agreement with VMware, and if you go with the AVP, you don't need to buy that license for the server. That's one of the main differences. However, if you're not going with AVP, but directly with ESXi, which you normally use if you already have some VMware infrastructure, then you do need to license not only the applications here, but also the server. That's why when you install AVP, one of the things that you need to do within the next 2 hours is SSH to the server and accept the EULA, because the EULA is actually what allows you to bypass that license that VMware makes you have for each server.
Cool.
So when you inherit a system, how do you tell what you have?
You'll see.
If it's a Avaya banner when you go to the hypervisor, if it's got a big Avaya banner or if it's got a VMware banner.
Normally, the path that
Connect
follows,
to the server.
if you had system platform before, you're gonna probably upgrade to AVP because you didn't have license you for the server, so they don't want you to have to buy a license for the servers. You probably go to AVP. And so this is normally used when the customer doesn't have a VMware infrastructure. If you have a VMware infrastructure, you'll just go with ESXi here, the hypervisor. But yeah, there are ways. I mean, there are ways to tell if you're using AVP or ESXi.
I think if you connect a monitor to it, that screen you see will tell you what you have.
There is another thing that, you know what, remember that before in 603, the console domain was the tool used to manage certain things here in the template. The console domain is gone. So now there is an application known as the SDM, and that SDM stands for Solution Deployment Manager, is what allows you to deploy and update and upgrade this application.
But
So
only on an AVP, correct? Not
only on an
ESXi.
AVP. Yeah, it's supposed to be only on an AVP. Yeah, and in the SDM you'll see if it's an AVP or a non-AVP. But yeah, the SDM is supposed to be only for the AVP. The SDM could be installed on your laptop as an SDM client, so an application that you run, and in System Manager 7, the SDM is also part of the menus in System Manager. So usually what you do is you install, before you have System Manager in 7, you install System Manager with the SDM client on your laptop, and once you have System Manager up and running, then you start using the SDM in System Manager, because it's more robust than the client. But it's okay. I mean, you don't have to complicate things with this SDM here. Just remember that the main difference is that we no longer use templates, as in 6.3, but instead in 7 we use a hypervisor that allows you to install as many virtual machines as your server allows you to have, depending on resources on that server, like memory resources, CPU resources, disk resources, and all that stuff.
That is the main difference, but the result of that is you can't use a web browser to do very much on your system, right? Whereas before, you could open up the web browser with CDOM, you could see whatever your applications or your templates that were loaded. Now, no, you've got to download client software to be able to get that far.
However,
System
but
Manager.
remember that System Manager has that
System
many.
Manager's browser.
Yeah, you could use System Manager to browse and use the SDM in System Manager. Only at the very beginning you use the SDM client.
You never just get to use a web browser with that. You have to,
Well, I mean, a web browser to System Manager.
if you have System Manager.
Yeah, once you've
But
got
you need to have System Manager in 7. Avaya is making you have System Manager in 7. Even if you don't administer CM from System Manager, Avaya is forcing you to have System Manager in release 7.
because it's also the licensing list. Didn't WebLM incorporated at some point?
Yeah, but that's not why they're forcing it. Because in 6, System Manager also had the embedded web element. So you could have your system as your main WebLM in both 6 or 7.
Where I've seen it affect us is if you have professional registry, you can connect a laptop to the services port and talking through something, and you got a client.
Okay. Failover. Says here, in the 6.2 release, Session Manager offers improved redundancy where 2 or more Session Manager instances are configured in a failover group. So, let me actually talk about it. In CM, when you have an LSP or an ESS, and a phone fails over to that ESS LSP, if the phone is on an active call and during that active call the main CM goes down, within that call, that guy, all that guy can do is keep talking, but there is no way to apply features to that call because there is no call server within that call. Avaya calls that a scenario connection preservation. Which means that somehow that connection or that voice path's preserved, but that user cannot do anything within that call more than just hang up.
Like what else?
Huh?
You can't put it on hold.
Transfer.
No.
You can't do anything.
If you're
lose
an
call
agent,
control.
you can't use
You lose call
function
control.
codes. Yeah.
All you can do is hang up, and then the next call signals through the ESS or LSP, so you again have a call server that allows you to apply features to your call, like put the call on hold, that's a feature, forward a call, park a call, blah, 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 all the stuff you can do in CM. That's known as connection preservation. In the CM world, the only environment that allows you to preserve features within the call is when you have a CM duplex arrangement, and you have a connection here between the two CMs, and because of something known as memory shadowing, which means that the CM who's not active is able to shadow the other CM's memory. Because of that, if this guy is within a call and the main CM goes down, the other CM knows about the state of that call and is able to take it from there. So in this type of arrangement, you are able to keep applying features within the call. Avaya calls this call preservation. The other one was connection preservation. This is call preservation. Okay? Only with CM duplex. The CM duplex is the CM that offers the highest survivability option. Now, why is that I'm talking about this? Because I now want to compare with Session Manager. So in Session Manager, before release 6.2, all Session Manager offered was connection preservation, similar to CM and LSPs. However, starting with 6.2, they offer a new feature called Failover Groups. With Failover Groups, you're able to put two Session Managers in a group, and by doing that, you're able to have call preservation.
What kind of connectivity requirements are there between those SMs? Do they have to be co-located?
They have to be what?
Co-located? Same place? Same
No,
rack?
no. They do have some. I've seen some requirements, but they don't have to be in the same place. They don't have to be in the same place. So remember, now call preservation is the new feature with release 6.2. And for you to make it work, you need to configure something known as a failover group. So you group the two session managers in a failover group.
Can a failover group include a BSM?
No, only two session managers. And you also need, for this to work, you need a DNS server. So basically what you do is, instead of working with the IP address of each session manager, you assign an FQDN. They actually call it FGDN for failover group, but it's an FQDN. You assign an FQDN to each session manager, and you resolve that FQDN to the two IP addresses of session manager by using an external DNS server. So for this feature to work, you need a DNS server, a functional DNS server. And that's it. So that's the feature starting in 6.2. It's not configured by default. it's not configured, and I see it a lot of the times just there, not configured, which means that your session managers are working in connection preservation, not call preservation. This is useful. Think about this. And by the way, these failover groups are not for the SIP endpoints. The SIP endpoints have survivability through whatever we saw before, primary session manager, secondary session manager. These failover groups are for when SIP entities want to communicate with session manager. Like for example, let me give you here an example. Let's say you have an IVR. And let's say that your session managers so let's say a user, a caller, goes through your IVR, your IVR sends that to session manager 1, let's say, and then session manager 1 communicates with the contact center application. And your contact center application, you have agents, right? And then the contact center application says, hey, all of my agents are busy right now. So normally what happens is that you connect the caller to music on hold. Let's forget about what's the system providing music on hold. Let's just here say that something provides music on hold. So now session manager connects to music on hold. And the caller is listening to that music. All of a sudden, the session manager 1 goes down. So if you don't have failover groups configured, no one knows, and this session manager doesn't know that the current state of that call is that that user is connected to music on hold. It doesn't know because we would be working in a connection preservation where the other session manager doesn't know the current state of the call. So the other session manager is not able to take it from there. So in that case, this session manager will take place, but that user will be listening to music on hold forever because there's no one who can disconnect it from there. So this is a scenario where you want to configure the two session managers in a failover group so that if this happens, if this session manager 1 goes down, the other one knows about the current state of all the calls and is able to take it from there. So in this example, the second session manager will be able to disconnect the music from music on hold and connect it back to the contact center application when there is an agent available. Configuring failover groups, if the session manager is already up and running and it was not configured from the beginning, then it requires a maintenance window because there are some ports that change between the SIP entities. So you will require a maintenance window, because there are certain things that need to change. The ports between the session managers change. The ports between the session managers and the SIP entities change. So, if for example one of those SIP entities is CM, let's suppose that this is for some reason CM, you need to be careful because those ports are going to change, which means that the ports in the signaling groups will have to be updated. So that's why it requires a maintenance window. Just be aware. Here we won't configure the feature, we just talk about it. I do have a white paper where you could just configure it. I could give that to you. Capacity. This is capacity related to system, actually to session manager. Total amount of users. This is 6.3 and 7 is different. Let's see, total enterprise SIP users. In this release, up to 125,000. In 7 is actually the double. It would be 250,000 users. Number of SIP users per session manager, this is still the same, 21,500. SIP users per CM, 36,000 users per CM. So notice that if you have, 40, let's say 50,000 users, you would need what, like 3 session managers and 2 CMs. Session manager instances, 12 in this release, 28 in release 7. Communication managers, notice that 500 CMs. 500 CMs managed by the same system manager.
Please don't.
That's
Please
crazy.
don't.
That's
Yeah,
a lot of admins.
But you know, it's good to know because sometimes you have a lot of standalone offices with the CMs, and Avaya had another tool called the what was the name? MSA, multi-site administrator.
Yeah.
Have you seen that one?
It's an awful product.
Yeah. This is better. System managing those multiple CMs is better than using MSA.
I found very few customers that have all that many CM cores. The vast majority of our customer base has flattened and consolidated to a single primary enterprise. So if they did have or acquired another CM, they're converting them to LSP ESSs off of a larger core.
Yeah, that's true, and that happens with customers that acquire companies, often. Call admission control. Have you heard of that? Call admission control. It's a feature that allows you to somehow manage a bandwidth threshold. In this case, to configure a threshold for the bandwidth between locations. And Communication Manager has the same feature, and you configure a bandwidth threshold between network regions. Here in Session Manager would be between locations. Locations are very similar to network regions. Okay. As a matter of fact, a good practice is to create as many locations as network regions you have in your CM. Have you seen the feature in CM? Let me actually show it to you, so that we actually get to see a system. Let's see. I'm gonna go to CM. So let me see if I'm able to ping CMs right now. I'm gonna go to the one in lab 1. So it would be 10.4, and it's answering. Perfect. So I'm gonna go 192.168.10.4. Login as was training 1, and I'm in. Notice that I'm using PATI, not ASA.
Right.
Because I can. And in PATI I use port 22.
Mm-hmm.
I could have used port 5022 and I would go directly to the SAT interface. However, since I use port 22, I came to the Linux shell where I could do some troubleshooting, but I actually want to go to the SAT, so I just need to type SAT. Can you see there? Let me just change a little bit the settings here. Maybe the font size to something larger so that you actually can see something. Maybe this one here, 60. A little better?
Yes.
Yeah.
Oops. Oh, and I messed up here because I went with the wrong emulation type.
Start again. Been there, done that.
Pitfalls of the putty.
So again, the command is SAT, or auto SAT would work as well. And the emulation type, usually when you use SANT, when you use ASA, you either go with 513 or 4410. With PATI, you could go with W2KTT. I used to use that one in Avaya, but there is actually a better one, which is SUNT, S-U-N-T. The reason why I like SUNT is because the mapping in SUNT is the same as in ASA. So F1 to cancel, F3 to save, F5 for help.
All your,
I might as well right now, that's the most important thing I'll learn.
Because
Yeah.
W2, because
I can't do escape backs.
because
I fail every time.
W2
I'm sitting there hitting that
KTT, you
F1
have to type
Frustrating,
X, E, X, something, you know, it's just a pain in the butt. But here you just cancel with F1, save with F3, help with F5, same way you do it in ASA. So if you're familiar with ASA, you're familiar here with SUNT. Okay, I just wanted to show you in CM, if you go to the network regions, let's say network region 1,
Next page. There we go.
here, in this place, we specify how network regions communicate with one another. Let's say that network region 1, it's going to communicate with network region 2 using a codec set. I don't care about the codec set right now.
Right.
I just care about this parameter because this is the call admission control parameter.
Right.
By default, it's set to no limit. But you could set it to, in CM, you could say, hey, I want to have that parameter set based on amount of calls, let's say. Right now, what I'm saying is that between network region 1 and 2, I can only have 5 calls.
Right.
Or 2 to 1, 5 calls. No matter the codec that they're using, because I'm working per call, you know, like I'm specifying the amount of calls. I could do it in a different way by saying, hey, actually I want to work with kilobits,
Yeah.
and I want to have this amount of kilobits per second within these two network regions. So if I go with something like this, 100 kilobits per second, now the codec matters.
Right.
Because let's see, usually if I use, let's say, G711, which is a codec with no compression, we normally say that it's around 90 kilobits
Yeah,
per
yeah,
second
one call.
per call. So in this case, only one call would be
Right.
allowed. But if I'm using G729, we normally say that it's around 30 kilobits per second per call.
Yeah.
So 3 calls would be allowed. So this is call admission control.
Yeah.
And you have the same capability in Session Manager. And in Session Manager, the difference is that you cannot do it like in CM when you say calls. It's all about bandwidth. In Session Manager, it has to be expressed in bandwidth. It's a bandwidth threshold that you configure between locations.
Okay.
And I'm sorry, so in Session Manager, it is only by number of calls?
Yes.
Yeah.
No, it's the
No,
opposite.
man,
It's
man.
only
No,
by
sorry, no,
bandwidth.
the opposite. Yeah, it's
Yeah.
only based on bandwidth, not based on amount of calls. Actually, let me show you the parameter in Session Manager. I said that you configure it in Session Manager in locations. So if you go to your locations, you give it a name, but this is the parameter, total bandwidth. You see, and all you can do is express it in terms of kilobits per second, megabits per second, gigabits per second, and terabits per second. And that's it. So here's where you would specify the total bandwidth. Like for example, you could say something like it's gonna be 1,000 kilobits per second. That would allow me to have like around 10 G711 calls.
Yeah.
And here, multimedia bandwidth is a subset of the total bandwidth only for video calls.
Oh.
In case you have video calls, you could say, hey, out of that 1,000, I want to use 500 for video. And then the next parameter, which is checked by default, says audio calls can take multimedia bandwidth, which makes sense because if you don't have video calls going through, you don't want to reserve that bandwidth for those calls, right? So you still want the audio calls to be able to use the bandwidth reserved for video. But anyways, this is call admission control in Session Manager, and it is not based on the amount of calls, but based on bandwidth threshold that you set up. Later, you're gonna see, or you're gonna have the question of, if CM is capable of doing call admission control and Session Manager is capable of doing it as well, where do I do it? But we'll talk about that later. Okay.
Okay.
Is it too cold? You good? Good. Okay, so that's called admission control. When you have multiple session managers, all of them share control over that bandwidth. Session manager security. So session manager handles the security primarily through the SM100. The SM100 is the front door of session manager for SIP messages. So it acts as a SIP firewall, but it's pretty much the main door of session manager for SIP messages. Every SIP message that goes to session manager goes through the SM100 first. And this is pretty much how things work. You have your session manager. Let's say this is the physical box. And you have your SM application. And then you have your SM100. So everything that wants to communicate with session manager will go first through the SM100. So for example, if you have CM and you want CM to communicate with session manager, it does it to the SM100 in terms of SIP messages, right? If you have any other application, Avaya or a messaging, SM100. Third-party applications that want to communicate via SIP, SM100. Actually, let's have a SIP phone here. A SIP phone, you point it to the SM100 for registration purposes. The SM100 then communicates with the SM application. Okay, this is all SIP, right? All of this is SIP, but it could be SIP over either TCP or TLS. SIP. If you want to encrypt those SIP messages, you use SIP over TLS. Question to you, why would you want to encrypt the SIP messages? Because you're not encrypting audio. Remember, SIP is all about signaling. Audio or video is delivered using another protocol, the RTP protocol. But SIP is all about signaling. So why would you want to encrypt those SIP messages?
Somebody doesn't hack and falsify themselves as an extension that you're on?
Yeah. The
Yeah.
truth is that later when you get more familiar with those SIP messages, you're going to see that they have information that could be useful to a hacker. It has information about the extension number ranges. It has information about CM versions, like application versions. So by looking at those messages, a hacker could easily tell the version of your CM and certain things that could be useful for someone who knows about certain holes in different applications. So that's why you want to encrypt those SIP messages. Now, if you encrypt those SIP messages, which means that you're using SIP over TLS, that goes to the SM100, and the SM100 decrypts the message using a public key, and it sends the SIP message with no encryption to the application.
It decrypts it using what, Nestor?
A public, what's the name? PKI, public key infrastructure.
Okay.
That when you have a public key and a private key. But forget about that. Let's just see it's TLS, it's encrypted, and the SM100 decrypts the message and pass it without encryption to the SM application. So the SM100 normally uses Ethernet 2. The Ethernet 2 port, it's the SM100. Session Manager has another interface, which is the management interface. I'm gonna put it here as MGMT for management. The management interface is used by System Manager to communicate to the SM100 application. And it would be used by you as an administrator if you want to go to the SM application to trace and do some other stuff. But most of the time you will go to the SM application because you want to trace, you want to run a real-time trace. Okay? So the management interface is normally associated with Ethernet 0. Let's put it here, ETH 0. So management is Ethernet 0, SM100 is Ethernet 2. Ethernet 1 is normally used for services port. Ethernet 3 is normally used for, that one is by default, you don't use it unless you want to configure something known as NIC bonding. But let's just say that the most important two interfaces are the management interface and the SM100.
Isn't that similar to the way that module messaging worked when it first came out, when we had connected the two together, but then there was, in a lot of different devices, where there's a kind of like an integration port and then a management port. Because that's really what you're talking about right there. The CM, the AAS, SIP, all integrate with the session manager, and then you have the management port.
Yeah, and similar, and this is kind of similar to what Avaya is trying to do in 7 with this new feature called as out-of-band management.
Yeah.
So they're separating, they're kind
That
of
feature's
trying
been
to
around
go.
a while, just not used by anybody, right?
Yeah. Yeah, so right now in 7 there is this new feature where Avaya allows you to, not for the session manager, but for some other applications where it allows you to differentiate traffic related to endpoints, let's say, and management traffic. And they now have, you could eventually configure an Ethernet port for each purpose. So,
And what's the third port on session manager that we might use?
yeah, so notice that Ethernet 0 is for management. Ethernet 1, which I'm not drawing here, would be services port. That would be the services port that allow you to go, remember that fixed IP 192.11.13.6? That's the fixed IP that you could use to go to the application. That one is especially used when you haven't configured anything and you want to log in for the first time. That's Ethernet 1, services port.
Yeah.
And Ethernet 3,
The NIC bonding.
it's another port that you could use if you want to enable NIC bonding.
Add
So-
more ports?
So there is this Ethernet 3 that you could enable, and if you enable NIC bonding, you're bonding together Ethernet 2 and Ethernet 3, so you have more bandwidth. And not only more bandwidth, but you have survivability. In case one of those ports go down, the other one still holds up. So that's known as NIC bonding. It's not enabled by default. And that would be Ethernet 3.
Is there a drawback to doing the NIC bonding?
I'm not completely sure about that, to be honest with you. I've heard people saying, yeah, we tried that and it didn't work very well, and that's why I didn't want to go there, to be
That's
honest
what
with
I'm
you.
wondering, because I haven't heard anybody do it.
Yeah, and I'm not completely sure what problems you could face if you do that. Okay, something important to notice here is that if you trace in Session Manager, you do it here in the SM application. And even though you're using zip over TLS, you're able to trace because this is pure zip, it's not encrypted. What I'm saying is that if you try to trace here, here, by putting a sniffer like Wireshark,
Alright, yeah.
you can't because everything is encrypted. You would have to change this to be zip over TCP, and then with trace with your sniffer. However, if you trace in Session Manager, you're able to see things because the SM100 decrypt the message, and now you're getting to see the message with no encryption. Okay? Now, if you go back to page, I think it's this, page 6 in your book. Let me see, I'm in page 48, but if you go back to page 6, notice that you have two interfaces for Session Manager. It says SM Ethernet 0. Which one is that one? Management. And then SM100. Now you know it's Ethernet 2, but that's the security module 100. You see? And here you have the two different IP addresses that you want to use.
Do you know why they call it 100?
No, I have no idea. But that interface, right now it's a software module that runs on Session Manager. But back in the day, it was actually a piece of hardware running on the server. But I have no idea why they call it the 100. Avaya bought a company, like around 7 years probably, called Ubiquiti.
Okay.
And that company, it was a company with headquarters in San Francisco, I believe, and that company had a zip server that Avaya liked a lot, and that's Session Manager now. You know, and after the acquisition of Ubiquiti, Avaya stopped developing the SES, which was the previous zip server, and they start now working with this zip server that they rebranded and call it Session Manager. So I guess that the SM100 name comes from there, you know?
Yep.
That's why the first releases of Session Manager were not very stable, because Avaya was still trying to integrate with Ubiquiti, you know, and release 5.2, 6.0, 6.1 were not very stable. Then started with 5.2, 6.0, 6.1, not very stable. Then 6.2 and 6.3 were very stable.
You know, the first release of anything that they did
It's-
after they bought it was terrible.
Yeah.
Happy Office.
Yeah.
Yeah, people losing their jobs, so they don't want to really help Avaya at that point.
IP Office 1.43 was awesome.
Oh.
Yeah. That week they put that one out.
So remember, SM100 is the front door of Session Manager, and it offloads most of the heavy security. And also now you know that it's able to work with zip over TLS, but it passes the message to the SM application with no encryption. That's why you're able to trace and get to see those zip messages. Quick review: how does Session Manager know which features are to be applied to each zip user?
Communication profile.
Yeah, it checks the user communication profile and see if there is any sequence configured in order to invoke a feature server. What's a feature used to control bandwidth or to network location?
Call admission control.
CAC. And I always say now call admission control, because I used to say CAC, but because of my accent, you know, I was like saying all the CAC and the CAC, and just put the CAC there and remove it. And people were like, oh, what's this guy talking about? And one time one guy told me, I started laughing at him at the end, like, hey, Nestor, don't say CAC anymore. Just so now I'm careful enough to say call admission control. You know, it takes longer, but prefer like this, or CAC.
Yeah.
How does Session Manager integrate multiple vendor platforms?
Application sequence?
Yeah, this is kind of those questions that I don't like, because it could be through sequencing, but the truth is that it's through modules, adaptation modules. We'll see those later.
Okay.
How does Session Manager handle zip registry routing?
By authentication the SIP user and routing through SIP URI?
Yeah. Yeah.
Yep.
I would think, yeah, B. Authenticating the zip user and routing using the zip URI What about the next one? How does session manager route calls to non-SIP endpoints?
Yeah.
Through the use of dial patterns and network routing policies. What component of session manager provides security to the SIP domain?
B.
The SN100. Okay, session manager maintenance and troubleshooting. This is actually it's not a chapter where you have to troubleshoot. They just talk about some tools that session manager has that could be useful. Let's see, in page 58, they have the session manager dashboard, which is what you see here. I don't like to spend a lot of time here because I prefer to do it when you actually are doing a lot. So session manager dashboard is a place where you can easily at a glance tell if something is going wrong with your session manager, with session managers, or with the SIP entities around your session managers. So you want to see everything in green, pretty much, if everything is going well. You start to see things in red when there are certain problems with session manager. I'll talk